The light touching our eyes right now left the sun about 8 minutes ago. Let that idea settle in like a warm, slow tide. A gentle fact that folds time into a small, familiar measure. Imagine a single photon, a single packet of light, beginning its life in the sun. And imagine, with a calm curiosity, following that tiny traveler all the way to your eye. This is a calming science story, a kind of cosmic whisper that asks nothing of you but to listen, to let the science for sleep and the meditative science of the cosmos ease you into a softer attention. We begin where the sun is most secret, at the core, where pressure and temperature are so high that hydrogen nuclei sometimes meet with enough force to fuse. In that quiet, incandescent crucible, two protons can become one helium nucleus, and a small amount of mass becomes energy. From that conversion, a photon is born, a pure packet of electromagnetic energy with no rest mass and no electric charge, behaving in ways that are both particle and wave. The language of quantum physics is gentle here. The photon is not a thing with a face or a plan, but a rule of nature, a ripple of possibility that begins to move the instant it exists. Inside the sun, movement is not a straight line. The interior is a dense, roiling plasma, a tangle of ions and electrons where light cannot travel far before being absorbed and re-emitted. Each absorption and re-emission sends the energy off in a new, random direction. So the photon's path is a long, meandering, random walk, rather than a single arrow. Estimates of how long it takes for energy to make that slow, patient journey outward vary. Scientists offer ranges from thousands to hundreds of thousands of years, depending on the assumptions about density and scattering. The exact number is less important than the feeling. A photon born in a single, bright fusion event may pass through countless interactions before a descendant finally escapes the sun's surface, like the last runner in a relay who carries forward the memory of the first stride. When that descendant finally reaches the photosphere and steps into vacuum, it travels at the universal speed limit, the speed of light, and it does so without friction or resistance. In empty space, light does not need to accelerate in the way we think of acceleration for objects with mass. It simply travels at its constant speed, a steady, unwavering pace that will carry it across the gulf between stars and planets. Physically speaking, we must be careful with metaphors. Talking about a photon's perspective is poetic rather than literal, because special relativity does not provide a well-defined rest frame for a massless particle. Still, the mathematics of relativity tells us that as an object with mass approaches the speed of light, time dilation grows without bound, and distances along the direction of travel contract. This is one of the most beautifully confirmed parts of modern physics, and it invites a kind of quiet awe rather than confusion. As our photon crosses interplanetary and interstellar space, it may pass through thin wisps of gas, remnants of long-ago stellar deaths that seeded the cosmos with carbon, oxygen, iron, and other elements. It may skirt the curved space-time around a massive object and bend its path slightly, following the geometry of the universe rather than a Euclidean straight line. It may thread through a nebula where newborn stars coax atoms into glowing, and each color is a signature of electrons settling into lower energy states. These are quiet, visual facts that become part of a relaxing science narrative. The universe is full of places where light is born, altered, and sent on its way. And each photon carries a small, faithful record of the conditions it passed through. If the photon began its journey in a distant galaxy, then what it brings to us is a message from the past. The star that emitted it may have changed, or even ended, long before the light reached us. When we look at distant galaxies, we are looking back in time. The light we receive is a fossil of a moment that has already passed. That idea, that looking outward is looking backward, is a gentle, sleep-friendly science truth. It turns the act of stargazing into a meditative practice. Each point of light is a story from a different era, arriving now as a soft, patient whisper. As the photon nears Earth, it meets our atmosphere, and the air itself becomes an instrument of color. Molecules of nitrogen and oxygen scatter shorter wavelengths more effectively, sending blues and violets sideways until the whole dome above us glows with them. This is why the sky appears blue. Longer wavelengths, like reds and oranges, scatter less, which is why the low sun at evening paints the horizon in warm, lingering hues. The scattering is a gentle choreography of light and air, a calming science scene that explains sunsets without urgency, and it invites you to breathe with the rhythm of the sky. Our photon threads through that atmosphere, perhaps scattered once or twice, perhaps nearly direct, and it finds its way into a room, through a window, and into an eye. The eye is a soft, precise instrument. The cornea and lens focus the incoming light, and at the back of the eye, a thin sheet of tissue, the retina, waits with roughly 130 million photoreceptor cells. Each photoreceptor is tipped with light-sensitive molecules, like rhodopsin in rods or cone pigments tuned to different colors. When a photon is absorbed by one of these molecules, its energy nudges the molecule into a slightly different shape. And that tiny change triggers a cascade of chemical events that the nervous system translates into electrical signals. Those signals travel along the optic nerve to the visual cortex, where they are woven into perception, into the experience of seeing. At that moment, the photon as a distinct entity ceases to exist. Its energy has been transformed into chemistry, into electricity, into the pattern of neural activity that becomes sight. What the photon carried, information about a flame, a leaf, a distant star, has been handed off and translated into something the brain can understand. This handoff is a quiet miracle of physics and biology working together. And it is the same process that brings every face, every landscape, every page of text into our awareness. The light from a candle across the room left that flame microseconds ago. The moon's light left its surface a little over a second ago. Starlight may have been traveling for years, centuries, or millennia before it reaches us. Everything we have ever seen has arrived in this way, as photons completing their journeys in the back of an eye. The light reflected off a friend's face left that face nanoseconds ago. Still a journey, still a crossing of space at the universal speed limit. Think of your sight as a constant reception of messages from across time, a steady stream of cosmic whisper that asks nothing and gives everything. Right now, you are bathed in ancient light and fresh light, photons from a billion different sources, all arriving at this particular point in space at this particular instant. The universe is reaching us constantly, and that reaching is gentle and unassuming. Let us linger on the sun for a while longer, and on the long relay that carries energy outward. Inside the core, fusion is not a single dramatic explosion, but a continuous, patient process. Countless protons meet and fuse, each event releasing a small amount of energy that begins a long chain of interactions. The photons that eventually escape are the heirs of many such events, each one a small, steady contribution to the light that warms our days. The random walk through the solar interior is a useful image for sleep-friendly science. It is slow, repetitive, and unhurried, like the rhythm of waves on a distant shore. Imagine the photons stepping from ion to ion, absorbed and re-emitted. Each step a tiny pause, each pause a soft reset, until finally the surface is reached and the photon is free to travel. Out in space, the photon becomes a messenger of conditions. Its color tells us about temperature and composition. Its direction tells us where it came from. Its arrival time is a record of distance. Astronomers read these messages with instruments that are extensions of our senses, turning light into data and data into stories about stars, galaxies, and the history of the cosmos. Yet the same physics that allows telescopes to decode distant light also makes for a very relaxing narrative. The universe is legible, and that legibility is a kind of comfort. When you look up at the night sky, you are participating in a cosmic storytelling that is both scientific and meditative, a practice of receiving and listening. There are small, tender details along the way that reward a slow attention. Consider the way a nebula glows. Atoms excited by nearby stars emit light at specific wavelengths, and those colors are signatures of particular elements. Or consider gravitational lensing, where a massive object bends the path of light and creates arcs and multiple images. It is as if space-time itself were a soft lens, shaping the light's journey in ways that are both precise and beautiful. These phenomena are not loud or dramatic in the way of action movies. They are subtle, precise, and deeply satisfying to contemplate as part of a bedtime science ritual. As you breathe with this story, notice how the scientific facts settle into a rhythm. The random walk, the escape into vacuum, the travel across space, the scattering in our atmosphere, the absorption in the retina. Each stage has its own tempo and texture. Let your breathing match that tempo. Slow in, slow out. A gentle cadence that mirrors the photon's patient journey. This is relaxing science. A way to let knowledge soften the edges of the day and guide you toward rest. Imagine now a slow montage of scenes. The sun's core as a distant, steady furnace. The photon stumbling outward in a long, patient, random walk. The sudden freedom of space, and the steady, unwavering travel at light speed. The soft bending near a massive object. The scattering in our atmosphere that paints the sky. The final, intimate moment when the photon's energy nudges a molecule in the retina and perception blooms. Each scene is a frame in a cosmic storytelling that is both scientific and meditative. Let each frame be a breath, and let each breath be a small release. There is a quiet humility in this view of the world. We are, in a sense, receivers of light, of history, of messages from places we cannot visit. The photons that reach us are patient couriers, carrying information across time and space without complaint. When you close your eyes, you carry with you the knowledge that your sight is a continuous reception of these messages, and that the universe is always, gently, reaching you. As this calming science story draws toward a close, let the rhythm slow further. Feel the weight of the day soften. Imagine the last photon of this narrative drifting into the dark, its journey complete, its energy folded into the quiet of your mind. Let the science for sleep and the meditative science of the cosmos be a lullaby, precise, tender, and unhurried. Rest now with the image of light as a constant companion, a cosmic whisper that has been traveling long before you were born and will continue long after. You are part of a universe that tells its story in photons, and tonight, those photons are telling you a gentle, true tale. Sleep-friendly science is not about answers that demand attention. It is about facts that invite calm. Let the knowledge of distances, of timescales, of the patient relay from core to eye settle like a soft blanket. Breathe slowly and let the universe reach you.